Welcome to Automation Best Practices. Today, I'm going to teach you the ever-living, very important automation best practices that can be utilized for any type of test automation tool, whether you're using IBM Rational Robot or QTP or UFT or Selenium WebDriver or any other tool that's going to come in the next decades of test automation. Automation best practices are extremely critical because they withstand the test of time and they always apply whenever we are doing test automation. So today I'm here to teach you these skills that have helped me and the dozens and hundreds of other automation engineers succeed and rise to the top of the ranks when it comes to automated software testing. So we're going to cover automation best practices, some page objects, Selenium weights, and other tips that I'm going to show you to really take your test automation to the next level. My name is Nikolai Advolotkin. I am the CEO of UltimateQA.com, where I teach test automation. So let's go ahead and dive right in so that you can understand how to do better test automation. First, we're going to talk about some automation best practice ideas. The very first thing that you need to understand and to focus on is the automation test pyramid. If you're not familiar with the automation test pyramid, it was developed by Mike Cohn a while back, and it basically says that the very bottom layer of the automation testing pyramid needs to be a majority of unit tests, and then on top of that, you're going to have less API tests, and then on top of that, you're going to have even less user interface tests. The idea of the automation test pyramid is that it basically helps you to create a good automation testing strategy for your entire automation program, right? Automation is not only UI automation. Automation entails unit and API layer and UI automation altogether. So you need to consider and focus on the automation testing pyramid. And you can see as we actually move up in different layers, what happens is the cost to develop increases, execution time increases, and possibility of false negatives increases. However, coverage does also increase and end user business relevance also increases as we move through the different layers. So that's very important to remember as we proceed through the rest of this best practices presentation. I don't like to just talk about some, nebulous topics without actually putting practical ideas and practical numbers. I love to see numbers myself, so I wanted to present you with some numbers. These are not, exact, researched, highly defined, highly statistically significant data, but this is from my experience. This is something that I've gathered over the years of working as an automation engineer, and I just wanted to show you the different types of test automation and how they compare to each other. So over here at the very top row, you can see the unit test layer. This is the very bottom of the pyramid, and why it's the most important layer of test automation to have is because you can see that a unit test can execute in as little as a single millisecond. So if you want to have a feedback loop of 5 minutes, you can execute approximately 300,000 tests. A unit test can be as small as a single line of code, and its reliability is pretty much 100%. I've actually never seen a flaky unit test because the unit test is so close to your actual test automation code that there's nothing in between your unit test and the actual code that might introduce any kind of flakiness. And so these tests are very easy to write, easy to automate. They have very few lines of code and they are extremely reliable. That's why we say that they should be the bottom of that test automation pyramid. On the other side of the spectrum, the most complicated type of automation are UI automated tests. A very quick automated test can be about 15 seconds. That's just something simple like opening up a browser and navigating to a URL and making sure that that page is loaded. A feedback loop, if you want to have one of 5 minutes, you can have anywhere from 0 to 20 tests. If all of your tests are running in 15 seconds, you can have 20 tests execute in that same amount of time. However, there are a lot of individuals, a lot of automation engineers that I work with that still struggle to even get a 15-second test. Some people have tests that are longer than 5 minutes. They have tests that are 90 minutes long. And so that poses a problem because it means that a continuous integration, continuous delivery environment will basically be impossible, because if you have a test that's 90 minutes long, you're never going to be able to deliver something in less than 90 minutes, because that's how long it's going to take for your entire automated test to finish. The simplest of UI tests can be 49 lines of code. Of course, that's plus or minus again, but again, this is just a very simple test. Opening up a browser, navigating to a page and asserting that it's open is 49 lines of code, and it can have a very low reliability of 0% to a pretty high reliability, but not still as reliable as unit tests. And the reason why there is such a big range is that there are some automation engineers that do automation not following best practices. And so they have a 0% reliability, meaning that whenever their automated functional test fails, it doesn't provide any actual valuable feedback in terms of the state of the application. Instead, what it does is it provides you a false positive, right? The test says the test failed, but it didn't fail because there's a bug in the application. It failed because there is actually a bug in the UI code logic that's being executed. But you can get it to a very high level as well. You can have 99.5% reliability. This is probably the best, the highest level of reliability that I've seen in test automation. And what that means is basically if you execute a single test 1,000 times, 995 of those, that UI test will provide you the correct feedback, right? If it's a bug, the test will fail and tell you there's a bug. And if there's no bug, the test will pass and say there's no bug. So that's probably the highest level of reliability that I've ever seen from UI automation. And I'll teach you how to get to that level through the rest of this presentation. So I love to have real code examples, right? Again, less nebulous knowledge and more real hard kind of facts and information. So just wanted to show you some examples. Up here are some unit tests. You can see that they are very simple unit tests. They are a single line long, right? And down here, you can see a very well-written UI automated test using Selenium WebDriver. This is a nice test using the page object pattern. However, you can see it has quite more lines of code. And then under here, you can see it's using these different kinds of objects and methods using the page object pattern. And inside of there, there's even more code. While under here, there's no more code than what you see right here, and inside of here there is more code. So basically, again, it drives at the idea that the difference between the very bottom layer of the automation pyramid and the very top layer of the automation pyramid, you can see that there's just simply more code. So it just means more time to automate the code and more maintenance time and more flakiness. So keep that in mind. So because of that, what we encounter is a commonly seen anti-pattern. It's called the inverted automation test pyramid, or the automation pyramid ice cream cone. Or sorry, it's called the ice cream cone of automation, because right, it looks like ice cream cone and then you can throw on, you know, some ice cream at the very top. And that's because people don't understand all the concepts that I just told you about how unit tests are basically the biggest bang for the buck that you get. And so what they try to do is they try to simulate end user behavior here at the top, and most of their automation is at the UI layer. And this is something that you want to avoid, because I already discussed why UI tests versus something like unit tests has a bunch of disadvantages. So after all this, you might be asking me, what are you talking about, Nikolai, right? We're all automation engineers. In fact, I myself, right, I teach Selenium WebDriver and UI test automation in a bunch of my courses. Why am I talking the automation test pyramid, and why am I discussing and telling you to do less UI automation and more unit testing and API testing? Well, it's because if you want your automation to succeed, if you want your automation program to succeed, you should follow the automation test pyramid. It doesn't mean that you should only do unit testing or you should only do UI testing. It means that you need all types of test automation in order to succeed, and you need them in the appropriate proportions. And it also means that as professionals, as automation engineers, we need to think about what we are automating, right? If we are automating a calculator functionality where we're adding 2 plus 2 and checking if that returns a 4, that can simply be done at the unit layer, right? That's inside of the code. You can check that logic inside of the code. You can even probably do it at the API layer if your calculator application is in like a web user interface, for example. That's not something you would want to do in the UI layer because there's no reason why that logic wouldn't work. However, the UI layer, you might want to do something like a login functionality, right? If you want to check that a user can successfully log in, you can use the user interface to log in as that user and make sure that he's taken through the appropriate flow. So that's what the whole reason behind me talking about the automation test pyramid is, that I want you to understand you need all layers of test automation to succeed in your automation program. Another very, very critical point about test automation, specifically UI automation, is that you always want to strive towards reliability, right? When you're trying to automate at the UI layer, the number one thing that you want to do is make sure that your UI automated tests are stable. If you want to achieve that 99.5% reliability from your UI automation and have your managers and your directors trust your automation and everybody be very happy at it, what you must do is you need to develop a test and make sure that that test is extremely reliable, right? You need to be running that test on a regular basis, daily at the very minimum, and you need to be making sure that whenever that test is failing, if it's failing, it's for a valid bug. If it's not a valid bug, what you need to do is actually stop everything that you're doing, analyze why that test failed, and fix the logic inside of your automated test to make it more stable. You can add more logging, you can add better synchronization, you can find better elements to use for your application. Those are some strategies that you can use and improve your automation before proceeding to automating more. I've worked with a lot of automation engineers, and I've even done it myself, where our managers are just simply asking us to automate a giant, massive regression suite. And so all we do is become like robots, where all we're doing is automating without actually ever stopping and thinking about, what is this automation accomplishing? Is it actually providing value to the business level, right? Am I actually providing value to the business? That's a very important goal to consider. And whenever your automation is flaky and it's not passing or failing for the appropriate reasons, it's not providing value to the business, because at the end of the day, it's not letting the business know what is the state of the application and can we release this application to production within the next 45 minutes. The other very important point here is, in order to strive towards reliability, you need to execute automation regularly, and ideally through something like a continuous integration environment. Whenever your code is being checked in, that means that your automation should be getting executed. It should be running in parallel, and it should be getting executed, and that will allow you to weed out the flaky automation from the non-flaky automation. It will allow you to make fixes on a regular daily basis and get your UI automation to a very stable level. And the final point that will help you to strive towards reliability is that you are the automation expert. And a lot of times our managers, they are fantastic people, and they have fantastic dreams in mind, and they want to automate everything through the UI layer, but they simply are not the technical experts. They cannot be the ones that are telling us to automate a suite of 3,000 regression tests, manual regression tests, and telling us to do it through the UI layer. That is not their job to do that. They hire us, the automation experts, to tell them what makes sense to automate and how to improve the quality assurance process of the entire program. And so you must be the expert and say, no, I will not automate this 90-minute scenario, because that is not something you want to do at the UI layer. If you want to test these different features, what I can do is I can break them up into many tiny little short tests, and I can tackle all of those together, and all of them combined will make sure that the functionality is working. But no, I will not create a 90-minute scenario. No, I will not even automate a 10-minute scenario. That's just simply something that I will not do, because I'm the expert, and the manager will understand that you're the technical expert, and they will trust you, and you need to be the champion, letting the manager know why something makes sense to automate and why something does not. So another very common topic discussed in test automation is whether you should automatically rerun your failed tests. So what that basically means is some individuals, a lot of companies, a lot of automation engineers, what they do is whenever an automated test fails, the very first thing they do is go ahead and rerun it, instead of actually considering whether it's an actual bug in the application. And that's causes several problems. First, think about the mentality that that creates for your test automation, right? If your test fails, instead of the team or even you assuming that what is the bug in the application, your very first thought is rerun it because my automation is not trustworthy. How bad of a mentality is that? That's something you want to avoid. The other problem that rerunning your failed automation automatically causes is it can actually hide true problems. I worked at a single place where I had a bunch of automated UI tests running, and randomly, like it was so random, we would have a UI test that would just fail, and I couldn't figure out why. So I spent several hours working with the developers and the ops team trying to figure out why are these automated UI tests actually failing. And after digging into it, what we figured out was that we had a website that was load balanced, and randomly, right, the traffic would go to a specific server that was load balanced based on our load balancing conditions. And when it got to that server under those conditions, that server was actually broken. And so that user that had that specific scenario would be failing, and that was a real bug in the application. Had I automatically rerun my failing test and didn't check why it was failing, we would have never caught the bug, and maybe to this day, our clients would still be seeing this intermittent problem with our web application. So my recommended approach here for your failed test automation is stop, figure out why the test automation failed, improve it by adding more logging, by improving synchronization, fixing the flakiness, and only then are you allowed to proceed with automating more. Let's talk some more about page objects. Page objects are an extremely important pattern, especially with UI automation. If you haven't heard of the page object pattern, it basically states that you should encapsulate your UI HTML web pages inside of classes, whether you're using, Java, C# or other programming languages. You're encapsulating a single web page inside of a single class. And so page objects are phenomenal for test automation because they improve maintainability, right? For example, if you have a Google homepage, what's going to happen is all interactions related to the Google homepage will be living in the Google homepage class. And so whenever you need to update anything in the user interface or inside of your test, all you have to do is go to that page object and update it there. And you know exactly where to update it because, right, a Google homepage page object relates to the Google homepage, google.com homepage. It also improves readability, as I'll show you more tests and actual real code of using the page object pattern. You will see that your tests become extremely readable, and also organization is improved, as I mentioned, because the structure of your test automation framework will be much more intuitive. So here is an example of a good page object. You can see that up here, this is a class called Ultimate QA Homepage, and this class represents this entire web page right here. Inside of this class, we have some properties and some methods. For example, we have this property called the Start Here button, and you can interact with this property by performing different kind of actions on it. It encapsulates this Start Learning Now button here. And if you want to perform a method on this page object, you can do something like an open, and the method does exactly as you would assume it does. Is it goes to a URL, and that's pretty much it, right? It opens up the URL of that page. So with that said, we must talk about some page object anti-patterns that are sadly extremely common in the test automation space. I've worked with a lot of clients and a lot of other automation engineers where we struggle with some of these problems. One of them is overpopulating the base page. What happens is the base page must be thought of as the parent page of all the page objects. So what that means is if you want to follow the Liskov substitution principle, that's more advanced, one of the solid principles, but it really relates back to the Liskov substitution principles. It basically states that your base page, everything that inherits from the base page must do all of those actions from the base page. So it means that base page can only contain the common components that all of the pages do, not some of the pages, not like 5 out of 10 of your page objects, but all of the page objects. So what that means is stuff like the WebDriver wait class. You can throw that in the base page. You can throw a navigation method into your base page, right? To navigate maybe to the root domain of your URL, like ultimateqa.com, and then the other pages tackle, /blog, /contact us, and so on and so forth. You can also add maybe some JavaScript methods into your base page object, or common components of all the pages. And again, I like to give you kind of rules of thumb and give you practical, applicable information for you that you can take home right now and start applying it. So one thing that I've seen work really well in the past is to apply a 200 line of code max to your base page, but not only to your base page, it actually applies to all of the classes. But in this case, say that your base page can only be 200 lines of code max, and that will make sure that not only does your base page follow the Liskov substitution principle, it will also follow the single responsibility principle and be small, and I'll talk about that actually in a little bit. The other problem, it's kind of the brother of overpopulating the base page, is overpopulating the page objects. A lot of individuals will start automating a web application, and instead of automating only what they need at that time, they basically throw everything into a page object from the beginning. So for example, you saw the Ultimate QA page. Instead of just automating one test at a time and adding those elements to the page object, some individuals, what they're going to do is they will start adding all of the elements and all of the methods to this class, their page object. And so their page object becomes thousands of lines long, and then a lot of those methods and properties end up not being used. And so all of effort was spent on automating and locating these elements and creating these methods, and then none of them are ever used. The final page object anti-pattern I want to talk about is having methods and properties that don't actually represent user actions. So if you remember, our classes are supposed to represent an HTML page, and that's pretty much it, representing an HTML page and how a user would interact with it. So stuff that does not belong in page objects are something like opening Excel files, connecting to SQL, converting strings to arrays, and so on and so forth. These have other classes where they should live, but not inside of the page object. One of the most common struggles that I see with clients and other automation engineers is working actually with synchronization. In terms of UI, it's just the UI is just hard to synchronize, especially a web UI, right? So many moving components, right? Ajax components, Angular components, all loading asynchronously, elements loading other elements whenever they're interacted with. It just becomes hard. And so it's very important to talk about waiting strategies. So in Selenium, there are actually two types of waits. There is an implicit wait. An implicit wait basically tells the WebDriver to poll the DOM for a certain amount of time. And it's basically going to poll the DOM until it sees that an element is visible on the page. And it's nice because it only needs to be configured once, right? So you can see that here's a code example of how it gets configured. You basically set your implicit wait and set how long it's going to be. And it's going to live for the duration of the driver. So it means anytime you do a call like driver.findElement, that will wait for up to 5 seconds for that element to be visible on the page. Now that I taught you about implicit wait, I'm also going to tell you that you should never be using implicit waits. I actually have several very thorough articles about why you should not be using implicit waits. If you go to ultimateqa.com and look at implicit versus explicit waits, which is the second type of wait, you'll be able to find this in depth, but of course I'll cover that here. Implicit waits cause one major problem, is that they only search for an element to be visible on a page. So if an element actually exists on a page but is hidden, it's going to cause you a problem, because your test is going to say that the element is not there when in fact it is just simply hidden. And so it's going to cause you a bunch of flakiness. And then the other problem with using implicit waits is, again, I have a topic covered this on the blog, is Jim Evans, actually the creator of the .NET Selenium bindings, tells us that you should not mix implicit and explicit waits, because what it's going to do is actually lead to undefined behavior in the different browsers. Different browsers implement implicit waits differently, so how an implicit wait behaves in one browser may be different from another. And so mixing implicit and explicit waits is going to cause problems and should not be done. And so if I just told you that implicit waits cannot always give you the solution, because they only tell you if an element is visible on a page. So if an element is hidden, it means you're going to need to use an explicit wait. And if you need to use an explicit wait, it means you can't use an implicit wait. And so the only solution is to use explicit waits with your Selenium test automation. Explicit waits are the code that you actually write to wait for a certain condition to occur before proceeding. These are very versatile because it can allow you to perform many different kinds of waits on an element before proceeding. So here are some examples that I actually have. You can see that up here I have an example one. This is the recommended approach that actually Selenium provides. So you can see we create a WebDriver wait class. We pass in how long you want to wait for an element. And then we use the Selenium's expected conditions class to see that an element is visible. So that's one example. And this expected conditions class makes life for us much easier, because we can just use it to check for different states of elements. And here's the expected conditions class you can see on the right. From Selenium, you can check many different kinds of properties and the different kinds of states of elements to make sure that, the element is in the appropriate state. Here's another more complicated wait that you can do in, an explicit wait that you can do here. You can see that we're configuring and creating a WebDriver wait, and here we're actually writing our own code to wait until some specific condition occurs. And here is a third example of an explicit wait as well. This is the code that we wrote. However, it's a thread.sleep, and this is the worst kind of wait and almost should never be used. I've seen two good use cases for using thread.sleep. One of them is when you actually need to wait for an event in an application. So for example, let's say I've seen one use case where a user filled out your username and password and then they logged in, and then they had to wait for like 40 seconds before proceeding into the application. It was like in the UI. So that's one good example of using a thread.sleep right there. Another great example is sometimes Selenium is extremely too fast for typing strings into our fields. So I've seen it actually be a good use case where you can create your own method to type more slowly utilizing Selenium WebDrivers. You can grab a string, break it up into multiple characters, do a for each loop, iterate through every single character, and as you iterate, just do a thread.sleep in there of like 500 milliseconds and slow down the Selenium typing. That's the two good use cases that I've seen for thread.sleeps. Other than that, there are no good use cases. You might convince me of some other good use cases. If you've seen them, please come to ultimateqa.com and talk to me there. I'm always happy to learn, but so far, those are the two that I've seen. So, with all of that said, what is the correct synchronization strategy that I recommend for you? Open up your page, synchronize on the slowest loading element using an explicit wait, and then proceed with the rest of your actions. So, a lot of people ask me here, well, how do you find the slowest loading element? One way I could recommend for you to find it is to use developer tools. Open up your page and open developer tools, look at the network tab, and refresh your page and see all of the elements load in. The last elements that you can synchronize on will be the last ones to load on the page, and then you can use those for your synchronization. A lot of times it also comes to domain knowledge, right? Whenever you're working on an application, you know which elements are the slowest and fastest to load. So you can use your domain knowledge as well. But if you want a technical way, using the developer tools can help you there. And here, of course, another concrete example using the correct synchronization strategy. This is a very simple test, but this is how your UI test automation should look majority of the time. You can see here I have a Sauce Labs page, and I'm opening it up. Here I'm doing a synchronization. Right inside of here I have an explicit wait that's making sure that the page is loaded, and then I'm validating that it's true. So let me tell you some other tips that are phenomenal for test automation. This doesn't mean that they're not important at all. In fact, this whole presentation is about an hour of some of the greatest tips that I can ever gather. If you know me, you know that I can talk about test automation for days. Literally, I can just sit down with someone and just talk about it for days. And so when I give this presentation, it's about how can I give you the most value in this, short little 45 to an hour minute presentation. And so these are all my best tips that I could gather. So don't think that anything in this section is less important. One of the very most important automation best practices, and this is just a coding best practice in general, but right, as we all know, automation involves coding, and a lot of times you can be considered as software development engineers in test, and so coding is very important, and that principle is not to repeat yourself. And as you can see, Bob Martin here says that duplication is the primary enemy of a well-designed system. If you're not familiar with Bob Martin, he is a phenomenal software developer. The guy is just so smart and so knowledgeable about everything. And you can see he has a wiki page, so you know he's pretty important. But if you haven't seen him, I strongly recommend go on YouTube, search for him, go on Google, search for him, and watch some of his presentations. This guy is just mind-blowing. So if you listen to anyone, you can ignore everything I say, but definitely listen to him. So the problem with duplication, right, is that it causes us extra work whenever it's time to change, right? Change in software is inevitable, but how we deal with that change and how we prepare for that change is what is important. And so if we decrease the amount of duplication that we have in our test automation code, whenever that inevitable change happens, it will just make our life much easier for handling that change. So duplication can occur at multiple layers. One of the easiest ways to find duplication is it's simply hard-coded and created in our actual test automation code. So here you can see I have a bunch of elements that I'm reusing over and over, right? So whenever this element locator changes, for example, I now have to come to this single test and update these locators here. And there's just a single test, right? Imagine if you have a suite of 150 tests. Now you got to find these locators. So you can avoid this duplication simply by putting this locator into a property of a page object, right? Call this the user email property, right? And that will return you this element. And then you can call this the user password property, and that will return you that element. And so whenever they change, all you have to do is go to that single location in your page object, update it there, and now that will be reflected in your 150 automated tests. Duplication can also occur at even a higher level, right? It's not as obvious if you're just looking at the code like this, but if you look from test case to test case, you can see that we actually do start having some duplication, right? Some repeating logic inside of your automated tests. Initializing some driver, there's some try-catch block. In here, we're doing some common stuff. In here, we're doing some common stuff that's the same as up here. So you can even encapsulate all of this logic and abstract it up into a page object as well. And so, for example, if you were using a page object, this is actually using keywords, right? Keyword-driven testing, right? Keywords equivalent to keywords are equivalent to methods here, right? And you can see this is keyword-driven testing, a bunch of keywords combined together to create it. That's a problem actually I have with keyword-driven testing. But if it lived inside of a page object, for example, this logic right here seems like it's a login, right? Go to my account link, type username, password, and log in. So this is a login. So here we, open courses page, coursespage.open, and then here is coursespage.login. And so now you remove, what is this? 7 lines of code and put it into a single method here, 7 lines of code and put it into a single method here. And so whenever this logic changes, right, maybe we add a captcha somewhere here along the way. And if you need to add a captcha now, you just update that one single method, login method, and that will be reflected in all of your tests as well. Another very important point, again, stolen from the awesome guy, Uncle Bob, is he says that the first rule of classes is that they should be small. The second rule of classes is that they should be smaller than that. I love that because it's so true. And the reason why you want to keep your classes and methods small is that it helps you first to follow the single responsibility principle. You'll notice, and I promise you, if you try this and just listen to my advice, if you just try it, you don't have to follow it, but just give it a try. When you have small classes and small methods, what happens is your classes and methods start following the single responsibility principle. And the single responsibility principle of the solid principles tells us that a component should have only a single reason to change. And of course, when you have less code, it makes it that much more possible. Also, keeping classes and methods small allows you to have them very focused and not lying about what they do inside. Let me give you an example of that. So take a look at this method right here. So what do you think this method does, right? If we just analyze the method signature, well, it returns some kind of a string, right? And it's called get language in use, and then it takes in some content, and then it takes in an expected language. So it looks like maybe you're passing in some content, and then I guess you might be expecting some language from that content, and it's going to tell you what that language is in use. I guess we don't know if it's like a math language or an English language or like programming language. We don't really know that from here, but okay, that's what I'm assuming. Maybe I'm interested to know your thoughts. Let me know at ultimateqa.com what you thought this method was doing. But now that we have a notion about what it is, right, and we see its usage, we see its definition, when we actually open it up, this is what it actually does. Let's take a look inside. So it's trimming some content, okay? Then there's some ranked language identifier factory that's being created, and then we're getting some kind of a pass and creating some XML. Then we're loading something. Then we're identifying something, okay, language. And then there's a most certain languages, and they're getting sorted first or default. Then there's something with these ISOs that's being determined whether it's English or Spanish. And then somehow, okay, we're overriding it. Wait, but then there's overriding a math language? What? So this is craziness, right? I think you would agree with me that when you look inside, you are so confused by what this method is doing. And so the method signature lied to us about what the method actually does. And when we looked inside, we just got confused. But not only did it cause the confusion, this obviously doesn't follow any single responsibility principle, because I don't even know what a single responsibility of this method is. So maybe something like this is better. So this is, again, a small method that I've decreased. This was actually from a real test automation project I worked on. I've decreased this method in size to see if it can better represent exactly what it's doing. So pretty much the same, but in this case, you can see we're returning a language type instead of a string, just an enumeration. And again, we're passing in a content, and we're passing in an expected language, which is set to no language determined by default. So we're trimming our content. Then from our content that we trimmed, we're determining the language, that the language get returned. And then if this condition right here is met, then we override the unexpected language that we got, and then we return it. Otherwise, we return the language that we got. So if we got an unexpected language, we override it, but otherwise we return the language. So does this make way more sense when you look at the method signature and what the method actually does? That yes, this method actually does tell you the language that is being used from the content. And so again, that's the power of making classes and methods small, is that they don't lie. But also this has a single responsibility, right? Because if anything related to determining the language from your content changes, we know exactly where to go to change it. How about this class right here? What do you think? Is this class too big? Well, this is a real class, taken from a real software development project. And what is the problem with this class? Well, again, it's multiple problems. First, it's called the super dashboard and extends a bunch of different stuff. So when you think of what the super dashboard actually mean, I myself don't know. It could mean multiple things. But then when you start looking inside, you can see it does many different kinds of things. Like it's getting customized language paths. It's getting some kind of states. It's getting some kind of a project. It's setting focusing. It's deselecting objects. It's getting configuration managers. It's setting titles. It's running a project. It's updating display layer. It's creating layouts. This does way too much. It does not follow the single responsibility principle. But not only that, it's just confusing, because when something changes, where do you go to fix that change? Do you come to this class? Maybe a method that changes in here, or maybe it's somewhere else. But when you also need to add something to your project, to your software development project, to your test automation, where do you put it? Maybe here or maybe somewhere else. It's so confusing, nobody knows. And so that's the importance of making sure that your classes and methods are small. Oh, and I also didn't mention, again, I try to provide you less nebulous information and more actionable. So again, we already talked about this. My recommendation that I've seen work really well from the past, and I actually got this idea from Uncle Bob, is 200 lines of code max for all of your classes, period. Give it a shot. It might not work as well for you as it did for me, but maybe it will work fantastic. And then you don't have to reinvent the wheel that I've already went through and trying to figure out what is a good size for a class. Give it a shot. And for methods, actually 7 lines of code plus or minus, plus maybe a line or two in a rare cases, is a great amount. So that means actually from the method signature all the way down to the last brace, 7 lines of code is a great amount for the method. What it's going to do again is it's going to make sure that your methods follow the single responsibility principle, and your methods are going to do exactly as they say they will do. And so give it a shot again. I've seen it work really well. It might not work so well for you. If it doesn't, just adjust from there. But again, I'm giving you a starting point, somewhere to jump into and be like, okay, let's set these rules up right now and just give them a try. It's a framework, and then if they don't work out, adjust them for yourself. But come back and let me know how it works out. I'm really, really interested to know how these rules work out for you, because they've worked out really well for me in the past. UltimateQA.com, come and talk to me there. So I know that I've presented so much information, and your ears just might be exploding, your head might be exploding. If you're writing these things down, your hand might be dead, but that's okay. And I'm here to summarize and make sure that I give you these 7 points that I've talked about, and for you to take them home and follow them, and it will drastically improve your test automation. Really, it will help to take your test automation program from low levels to extremely high levels, simply by just following all these 7 principles. I promise you, I've transformed myself automation programs simply by just following these principles. So again, follow the test automation pyramid. Remember, pick the appropriate layer to do your test automation in. Focus on test reliability over more automation, meaning if you have a flaky test, stop, fix it. When the test is fixed and providing you valuable results, only then proceed to automating more. That involves saying no to your managers. Your managers, if they're not technical, have no right and no expertise in telling you what to automate and how much to automate. And if they are technical individuals, they will understand if you tell them and let them know logically. You don't have to, rudely tell them, no, I'm not going to automate this. If you logically explain to them why something doesn't make sense to automate, your technical managers will understand. Don't rerun failed tests. Again, make sure that if you have a failed test, stop, fix the flakiness by adding more logging, removing the flakiness, improving synchronization, and then introducing it back into your test automation suite. And of course, you want to use page objects. Page objects are the best way to do UI test automation. Period. There is no better way right now. I haven't seen it. There have been other ideas presented, but all the best automation engineers that I know, Angie Jones, Alan Richardson, all the solution architects that I work with, we all use page objects. There simply is no better way. So use page objects. Use only explicit waits. Those will help you with synchronization with Selenium. Make sure that you stay dry, right? Remember, don't be wet. Don't write everything twice, and don't write everything twice. And the dry stands for don't repeat yourself. So stay dry and keep your classes and methods small, because what that's going to mean at the end of the day is they're going to follow single responsibility principle, and they're also going to clearly convey what the code is doing. So that's it. Thank you so much for your time today. I truly enjoyed presenting this content to you. Again, these automation best practices are some of the gold that I've gathered over my years of test automation, talking with test automation experts, some experience myself, and I've put it into this presentation that I hope will help to transform your test automation for you. I'm always interested in what you have to say, so please come to ultimateqa.com. Let me know your thoughts on this presentation. I also have a bunch of free courses on ultimateqa.com where I teach this plus other automation related topics, and you can come check them out there. Just go ultimateqa.com. You'll find a bunch of the courses there and pick and choose whichever ones you want. I have most of them are free. And again, thank you so much for your time. My name is Nikolai. Super happy to be here, and talk to you later.